Hi again, this is Sami. I'm gonna derive how to get the derivative of y equals tan x. We all know by law, by rule, is the derivative of tan x um, of y equals tan x, then y prime or dy dx equals secant squared x. Now we want to prove or derive how that is, and so what I'm gonna do, I'm gonna first of all change the tan into sine x tan over cos x, because that's what the tan is from your identity sheet. So tan x over cos x. And also, for any of you who don't know the quotient rule says if y equals f of x over g of x, and you want to do y prime, which is the derivative, then it becomes f prime of x times g of x minus g prime of x times f of x all over g of x squared. So now let's follow that quotient rule right here and take the derivative of this. So y prime would equal the derivative of f of x, which is sine x here, is cos x, times the g of x, which is cos x, minus the derivative of cos x is negative sine x, times f of x, which is sine x, over g of x squared. G of x is cos of x, so I need to square that. And therefore, what we get here, we get cos squared x, negative and negative is plus sine squared x all over cos squared x. The square outside here doesn't go in the x, it goes in the cos, because it's the cos here, it's not the x. You're cosing the x, you're cosing the angle x. So, or taking the cosine or cosing, I don't know if that's a word, but you're taking the cosine of x, so it's the cosine that gets squared here. Now from the identity sheet, you know cos squared plus sine squared gives you 1, and it's 1 over cos squared x, which equals, 1 over cos is secant x, and 1 over cos squared will make it secant squared x. And therefore, y prime is secant squared x, and that's the proof of how we got the derivative of tan x to be secant squared x. Thank you for watching again. Stay tuned for my next video. Also, don't forget to support the channel. Hit the like button, subscribe, and share with others so they could benefit. Thanks again. Bye-bye.